Hello everyone, I'm Tasmia Shakerin from Group Akatsuki, Section 4. Here we'll be discussing about our project real-time fire detection system using temperature, humidity, and gas sensor. First, I'll be discussing the Arduino part from my end, and the rest will be done by my teammates. So let's get started. In Proteus part, we will be discussing about how we can connect sensors with Arduino. So in Arduino, first we have to define pins. And then we'll be taking inputs from the sensors, and as output devices we'll be using red and green LEDs and a buzzer which will function once the fire is detected. First we will be taking out input from the gas sensor and store it in a variable. Similarly, we will be taking input from temperature sensor, but as it was analog we had to convert it. After taking humidity input from humidity sensor, we calculated the relative humidity with respect to temperature. Then we will be checking the gas input, and if we find it high, we can assume that the smoke was detected and fire may have occurred. So the red LED will be kept high to exhibit the risk, and green LED will be kept low. The buzzer will be turned on for us to notice the fire. But if we find the gas input to be low, then we can conclude that no smoke was detected. Similarly, if temperature is found greater than 55 degrees Celsius, it will display temperature is too high, and if RH is greater than 80, humidity exceeded normal condition will be displayed. We will display the temperature and RH that we have calculated and show if any fire or smoke was detected. As we will be continuously taking inputs and show outputs accordingly, we can use this process. We can keep this process in a loop for this process to occur repeatedly. But we are using a 200 millisecond delay here for any action to be taken if any fire is detected. After compiling, we can use the hex file in our Proteus to work in our project. That's it from me.
Assalamu alaikum. My name is Rafia Tasneem and my ID is 18101-288. So based on our topic, which is real-time fire detection system using temperature, smoke and humidity sensor, our Proteus circuit is designed accordingly in connection to Arduino. So here we have used LM35 as temperature sensor, HIH5030 as humidity sensor, and MQ2 gas sensor is working to detect smoke, which is connected to a logic state. A buzzer is connected to notify the fire alarm along with two LEDs, LED red and LED green. The RxD pin from the virtual terminal is connected to the TXD pin of Arduino Uno, and the RxD and TXD pin from the COM pin is connected to the RxD and TXD pin of Arduino Uno. So after uploading the hex file from the gas sensor library to the gas sensor, and also the hex file of our Arduino code to the Arduino Uno, if we run our project, then you will see that it displays the values of temperature and humidity along with a message that no smoke is detected because our logic state is in low condition. So this is why the LED green light emits to notify that the environment is in safe condition. Now if we turn the logic state to high, then you will see that the buzzer will buzz a sound to notify the fire alarm along with the LED, red LED, which will emit to notify that the environment is in danger. So let's see. We can also see that here it shows a message that smoke detected, fire alert. So this is how it notifies us about the fire. Moreover, we have also set an optimum temperature of 57 degrees Celsius and optimum humidity level of 80. So if we exceed these values, let's see what happens. So if I raise the values of the temperature to above 57, then you can see here it shows a message that temperature is too high. Now if I raise the values of the humidity to over 80, then you can see that it shows that humidity exceeded normal condition. So this is how our project mainly works, and this is how it notifies us about the fire and temperature and humidity. Thank you.
Assalamualaikum everyone, my name is Barha, Meherun, Pritha, and my ID is 181012232. So this is the block diagram of our lab view, and this is the table control. The first two elements are date and time, and the next three elements are connected to temperature, smoke, and humidity, and the last three are our ID numbers, which are constant and it doesn't change. So the temperature, for temperature we have a chart and a thermometer and an LED light. The LED light will turn red if the condition is greater or equals to 57. Otherwise it will stay green. As you can see, if the condition is true, then it will become red, or otherwise it will stay green. Same case for the smoke. We have a vertical progress bar and a smoke chart, and if the smoke is greater than or equals to 0.8, then the LED light will turn red from green, or otherwise it will stay green. And for the humidity, if the humidity is greater than 80% or equals to 80%, then the humidity LED light will also turn red, or otherwise it will stay green. And we have a meter for detecting the humidity and humidity chart. So these conditions are connected by OR gate, two OR gates. So if any of this condition is greater than any danger value, then the LED light for fire indicator will turn red, or otherwise it will stay green. So this is connected in a while loop, so it keeps on taking the readings. So this is our front panel of our lab view, and this is our Proteus. So to run the project, first we need to pair COM port 1 and COM port 2. Then we'll need to select COM port 1 from in the Proteus comping component. You will select COM port 1 and we'll need to select the physical baud rate 9600. Then we need to select COM port 2 in the lab view part. Then we will run this and we'll run the Proteus. So as you can see, the values are coming up. The first is the date, then the time, then the temperature reading, then the smoke reading, then the humidity, and the last three are IDs. So we need to now change the temperature value. So if we change it to greater than 57 or equals to 57, then you can see that the LED light for temperature becomes red, and we can also see the changes in the thermometer, and we can see that the fire indicator has turned red because now fire is present, and we can also see changes in the chart. Now we will decrease it to again below 57, so it will turn green, and the fire indicator also turn green. Now for the humidity, we will increase it to greater than 80 or equals to 80. Then you can also see the changes in the table, and you can see that the humidity LED light has turned red and the fire indicator also has turned red. And we can see the changes in the humidity meter and also in the graph chart of the humidity. Now we will decrease it again to below 80 and it will turn green. Now for the smoke, if there is smoke present, then we can see that the condition for the smoke vertical progress bar has become 1, and the LED light has turned red for smoke, and the fire indicator has also turned red, indicating that a fire is present. And we can also see the changes in the chart of the smoke and also in the table. So that is all for our project. I hope you guys liked it. Thank you.